Go. Okay, the first thing I wanted to show you is right here out of the textbook, and this is on page 111. And this is how you represent an if decision in a program. That's what this particular chapter is all about. It's all about programs that make decisions. They have to do that by using what's called an if expression. And this is what's called a flowchart, which is a tool that not so common anymore, but it used to be used a lot. It shows the flow of the program as the arrows. If you follow the arrows, it shows the flow of the program. The diamond represents the if expression. That's the if statement. So if it's cold outside, when you look at that, you have to put an if in front of it. So that's if it's cold outside. Well, if that is true, wear a coat, wear a hat, wear gloves. If it's not true, carry on. Okay, you don't need a coat, don't need a hat, don't need gloves. So there's two lines of execution here. Branching, that's what you get when you're working with decisions. Many programs, almost all programs of any real importance, feature many decisions, and they branch like this. They go one way if a condition is true. This condition here evaluates as true, all this code executes. If it evaluates as false, then this code executes. And that's very, very common in computer programming. Okay. Now, in order to make these if expressions, you have to use these relational operators. This is on page 112, just over the page. And you'll notice these relational operators. I think you'll know some of them from mathematics class, probably the first, maybe the first four of them anyway. Greater than, less than. By the way, if you get those mixed up, and I recall that I used to when I was studying math years ago, the way I remember which one is less than and which one is greater than is which one looks like an L? Clearly this one does, right? This one's backwards. This one does look like an L. Okay, now you got also greater than or equal to, less than or equal to, and equal to is a double equal sign. So that's a test for equality. Remember, a single equal sign, we've been using that for a little while, to assign a value to a variable. A double equal sign is required if you want to test for equality. Oh, I just got kicked out for inactivity. We can get back in. Okay, so the double equal sign is for testing for equality. The not equal to, the exclamation mark means not, so that's not equal to. So those are your so-called relational operators, and you use those to make up if expressions for programs that need to branch. Now, what I'd like to do for a starter here is I'd like to just fire up Python. Here's idle. And this is how you get started, by the way. I think some folks are not running their programs the right way. We want you to use idle. So you always want to start up idle. And what I want to do is just test some of those relational operators that we see there on page 112. For example, I can do something like 12 is greater than 10. See, that's true. The whole thing with an if expression. An if expression will always evaluate to true or false if it's properly encoded. Now, I'm not using variables at all here. I'm just using literal values, as you can see. But if I did 5 is greater than 8, well, that of course is not true. That's false. So these relational operators that you see here on page 111 or 112, they all are used to make if conditional statements, and they will always evaluate to either true or false. So that's what we're going to be doing with our code. Now we're going to be using variable names instead of literal values like this, or at least one variable name in our program. Any question about that? Any question about that, folks?
Nope. I'm good.
Okay. Okay, very good. Okay, so let's take a look at the first program that I would like to take a peek at here. I've got one, I can just shut that down. I've got one called if1. And I'll make these available after as well. Okay, take a look at this first little program here called the if1. And I'm using the main function. I know the author doesn't do this, but we would like you to do it. Always type def main open and close parentheses colon. And then everything that's tabbed in, indented, is in the main function. And then you run it down here. So take a look. What we've got here is an input. Are you happy? And we expect that whenever you have an input like that, you need to let the user to know how to respond. I mean, there's a lot of ways you could answer the question, are you happy? You can say, yeah, sometimes, nope, definitely, you betcha. I mean, there's all kinds of ways you could respond to that, right? So you have to tell the user how to respond to limit the responses, in this case, to a Y or an N. Now, look at our if condition here, our if statement. If mood, the variable, equals Y. That's a test for equality. So if the user types in a Y, this will evaluate as true. And I've got indented. This is a second indent to put it inside the if block. In this case, the if block only has one statement in it, but sometimes an if block could have hundreds of statements in it in a complex program. So if this is true, it should output this. So let's just give this a quick run here, see what it looks like when we run it. So I'll try yes. Okay. So this code executed because this evaluated as true. And just to verify how that worked out, I printed out the mood equals Y, and you'll notice that does give us a true. I'm going to run it. Yeah, go ahead. Sorry.
Along these lines, I had a question that I was hoping we'd get to something like this, and I didn't know if there was if there's a workaround. I know it said chapter 8 we could do things that were like unaffected by case, that were case insensitive, and that's in chapter 8, and that's later. So if you were to do in this, if you were to do if mood equals lowercase y in quotes or and then uppercase Y in quotes, I tried some version of that a million times and I couldn't get it to fly. Is that a thing?
Yes, it is a thing. If you wanted to make it really user-friendly, that's often done in programming.
I couldn't get it to fly, no matter how I did it probably 30 times. Which I couldn't get it. I could get it to work with just the lowercase.
Okay. Well, actually, what you're talking about is called using a logical operator for a more complex expression, right? In other words, we're gonna make this expression here a little bit more complex and also allow an uppercase, right?
Right.
So, and now would that be like an OR situation?
That was my plan.
Yes, it would be OR, wouldn't it? So what we should be able to do here, we should say OR mood equals.
Oh, I got it. See, that's not what I did. I did Y in quotes. Like, well, my example was that or that. Each individual, it was green, and then the or was yellow, but I didn't write another mood equals.
That's the secret. You have each part. This is a complex expression here using the logical operator OR. We're going to look at those in a bit. So,
got it. Okay.
Okay, but whenever you use OR like this, each expression has to be complete. So that's a complete expression. Those that's a complete expression. In other words, it has to have a left-hand side and a right-hand side of the equality operator. Okay, yeah, so that's a definite situation. So this should allow. This is quite interesting. I'm going to run this again, and this time I will put the capital Y in. So it says I'm glad, but look, I've got a false here because mood wasn't a lowercase, right? Yeah, I've got a false here because mood is not equal to a lowercase y. Okay with that?
I'm right here.
Okay. So this is obviously a pretty simple little program, but we could have many, many statements indented. They'd all have to be indented. And that puts them inside the if block. As soon as you unindent, which of course this line is unindented, as soon as you do that, it's not inside the if block anymore, and it'll always execute. Okay. If you're all right with that, I'm going to carry on. And
Do you mind if I ask a question about the?
by all means, ask a question.
Oh, sorry, Jason. Did you have a follow-up question? I guess not.
No, I did not. No, I did not. I'm leaving it on mute because if my tones go off, it's gonna really irritate everybody if I get a call. So I've been leaving it on mute. It takes me a second.
All right. So my question is on the actual operator. So I was trying to, as I was going through the chapter, I was trying to think of a use case, like a real, real life use case. And like, would something along the lines, like if you're filling out a form, do you have insurance? And then, if equals yes, then prompt a path. If not, prompt a different path.
Yeah, maybe not prompt a different path, but absolutely right. If you're filling out a form on the internet, there are programs that run on the web server that will, you can use Python for that, by the way, and there's many different languages that you can use. But when you fill out that form on the web, based on your inputs, decisions are being made by a program on the web server. Absolutely true.
Okay. What about an on or off toggle?
On or off? Yeah, well, that just means that a particular variable is either true or false.
Okay.
Yeah, that's the way, and that's what the way checkboxes work.
Yeah, that's exactly what I was going with that. Okay. Perfect. Thank you.
Okay. I'm teaching PHP right now. We do that all the time. Okay. If you're okay with this one then, any more questions? If this is true, this code here executes, and we could put multiple lines in here if we wanted to. Okay, well, if you're all right with that one, then I'm going to shut this down and, oh, maybe one more thing here. Let me just run it one more time. And let's put an N in this time. Notice I didn't get this output. I did not get the I'm glad, me too, right? Because it doesn't execute. This is ignored because this was false. I'll actually run it one more time. And if I just enter something incorrect, all I get is the false. This still evaluates as false, obviously. Okay. Let's take a look at another one here. Going to fire up if 2. But before I do that, I want to take a look at page 118. Let's take a look at page 118. There's a graphic there on page 118. Now this shows what usually you need in a program. Here's the flow of control coming in, temperature less than 40. So the way you have to look at that is, this is the if expression here. If the temperature is less than 40, if that's true, branch this way. If it's false, branch this way. And we haven't seen that yet. So this is where you use an else clause. If it's true, you've got this code block, execution goes this way, and then carries on down here. But if it's false, this is where you use an else block. So if we take a look at number 2 here, there's program number 2, where I've just added an else block. It's the very same thing as number 1, except I've added this code here. I've got an else block with 2 statements in it. And if this evaluates as false, well, then the else block executes. Because very often that's usually what you want to do. Quite often, if a certain thing is true, you want the program to branch one way. If it's not true, in other words, if it's false, you want something else to happen. Well, you put that something else code in the else block, and once again, it has to be indented. The indents in the if and the else block, they should line up. Otherwise, your program will crash. This program would crash if I did that. The indentation has to be consistent. So let's give this a try. And we'll try, I'll go with a no. So you notice we got the 2 lines of output, and it did evaluate to be false, of course. Okay, this is very, very common. You use if and else. Any question about that one?
Yeah, and I probably should have asked on the example before as well, but so if we have an if and we have an else path, what is prompting the word false to print?
I'm sorry, say that again, please.
So
Oh, right here. See, there's the test.
I see it.
Mood equals y. That's what prints the word false.
Got it. Okay, so the else statement doesn't have an output for print. It's just the print is coming from the if.
Well,
That was not a good way to ask, but I understand. I understand
okay.
what's
Okay.
happening. So if was false, so we're still printing the word false. Okay, got it.
Yeah, and because it was false, we get these 2 lines of output. Right? Sorry to hear that. Look on the bright side. I'll run it again. Run it again, and I'll put a yes in, and you'll see this time the final line is going to be a true. So because this line here now prints as true. Right? Because mood does equal y. I did enter a y. Okay?
Got it.
Okay, good. So that's very common in programming that you'll see something like that. Let's try another one. Actually, I've got a sort of a similar one here. Just kill this window here, and I'll open up if 3. Here's if 3. This time we're going to detect an even number or possibly an odd number. And this is something that's commonly put into a computer programming course that has to make a decision. We're going to ask the user to enter an even number. And some people are surprised to learn this, but a computer has no idea that 4, 6, 8, etc. Are even. Computer has no idea. The only way a computer could make that determination is if it's using software, if it's running a program that makes the determination. And the determination is made as follows. If you divide the number by 2 and the remainder is 0, you know you've got an even number, right? Let's think about it for a minute. It's 16 divided by 2 divides exactly 8 times with no remainder. So that's the test to see if a number is even. If num percent 2 equals 0, that percent operator gives you the remainder after a division. And if it's 0, then you know you have an even number. And if it's not 0, then I guess it's got to be odd, right? So you've got an odd number. And we could have said that here. We should have said num. We could have said, sorry, num is odd instead of not even. There's no other possibility, right? So let's try it. Give this one a run. So I'll try 15. No, incorrect. Run it again. Try 18. Yeah, 18 is even. Now, once again, I don't have much in the if block or in the else block. We could have multiple statements inside these, but we're just trying to show the simple operation of if and else. This is a good one to remember. If you divide the number by 2 and the remainder is 0, then you know you've got an even number. Now, if I wanted to check for an odd number, I could make this a 1. But I decided to go. It's a 6 of one, half dozen of the other. I can do it either way. Everybody okay with that one?
Yeah.
Okay. You see why it runs the way it does? That's the objective here. Do you understand why this program runs the way it does? And if you do, we're good to go. Let's move on. And for this, I'd like to go back to the ebook here for a moment. And very often we have to test a series of conditions. Sometimes there's more than two possibilities, like it isn't just an if and an else. Maybe there's multiple possibilities. Well, if that's the case, take a look at page 131. Page 131 at the bottom of the page mentions the if, elif, else statement. Elif is a short form that Guido created for else if. Instead of using two words, he contracted it to elif. And over the page, you can see how this can be coded. Here it is being code that's determining the grade for a particular score. If there's an if block. Now, if that is not true, there's an elif block, then there's another elif block, another elif block, and finally an else block at the end. Okay, that's called if, elif, and else, and it's for decisions when there's more than one possibility. Okay, so let's, any question about that before we try an example?
Nope.
Okay, well, let's try. Let's try an example here. I've got one called if for. And here it is. What we're going to do is we're going to assume that we have a couple of different age categories, categorizing people by their age. And let's say that if somebody is 19 or over, we'll call them an adult. If they're over 12 or over, greater than or equal to 12, well, that would make them a teenager. And if they're not 12, under 12, then that would be a minor. So that's the else block. Now notice I put these in order, decreasing order of age, 19, 12, and then under 12. So let's give it a try. I'll try 23 adult. So this code here obviously executed because 23 made this expression here true, right? Greater than or equal to 19. Let's try it again. So let's move this over and keep everything on the same screen. Multiple windows here. Okay, so let's try it again with, we'll try 16. That's a teenager. It's greater than or equal to 12. Try one more time. And it's 8 years old. That would be a minor. So more than two possibilities, not just an if-else situation. And you could have many of these elifs, as many as are necessary. I could make many more categories, I guess, right? I could make middle-aged, senior citizen, and so on. I could add all kinds of categories. If I did do that, I would put them in order, usually from increasing, high order decreasing down to the smallest age group. Now, you might wonder about this teenager thing. You might think, well, wouldn't it be better to say if age is greater than or equal to 12 and age is less than 20? That would be true for a teenager, right? The thing is, it's not necessary because your program will never get to this line unless this is false. So there's no need to say less than 19 because you're only going to get to this part of the program when it is less than 19. So you don't need to have a complex expression using a logical operator like we did with the upper and lowercase y moments ago. Okay. Any question about this one? It's kind of a weird part of the language there, elif instead of else if. Other programming languages just use the two words else if. But we don't want
So the
Python.
program is evaluating each statement, and as soon as it finds a true, then just stops there and goes to the next statement that is not within the if else.
That's right. Only the indented block of code will execute if this is true. If this is true, you are an adult. If this line here is true, you get this.
Okay.
Everything else is skipped.
That makes sense.
Okay. We could let's see. Why don't we try just to prove a point here? Why don't I add another one? If age is what the heck is a senior citizen these days? I guess it depends. If you're buying a coffee at McDonald's, it's 55. Let's go with 55. If age is greater than or equal to 55, then we could say you are a senior. So we could add to the program. Now this one here, I would now change it to an elif instead of an if. Okay, always start with an if and then have a series of elifs after it. Let's see how this goes. Give it a run again. Okay, so I'll try 64, senior, which is what we would expect. I'll try 28, so the adult still works, as you can see. So everything should still work. It's quite all right to have as many elifs as you want. But the thing is, you should always finish with an else. And that actually applies very nicely to the practice assignment that we were talking about earlier, before some of you got here. This is the preparation assignment for Module 3. And you'll notice that we're selling coffee at various prices. Well, notice the weights are, the price per pound differs depending on how many pounds you order. And you'll notice that I've got them going 40, 20, 10, 1 to 9. Well, make this an if. This one here will be an elif. This one will be an elif. And this last one will just be an else. So you would have something like if pounds greater than or equal to 40. And then you could say price equals 750. Elif pounds is greater than or equal to 20. Price equals 875. Elif pounds is greater than 10. Price equals 10. Else price equals 12. And it would have the very same structure as what you have here. And then after all of the after the final else, you could then multiply the pounds by the price per pound to finish it up. Okay.
Yeah.
Any question about this one?
Nope.
Okay. Let's go back to the example that was in the textbook, and maybe it'll make sense now here. So to see this example here, we had some. I think the entire program is in here somewhere. It's on the next page. Nope, it's on the previous page then. Yeah, here it is. Here's the entire program. Now, unfortunately, the version that they got here, this is another way of doing it. Instead of saying else and then elif, you can use else if with 2 lines. But it's kind of ugly, as you can see. It's a little harder to follow, I think. Much easier to do it the other way. But notice they're using some constants for the scores. An A score is 90, B score is 80, etc. Same as the scale that we use here at the college. So there's the if and elifs that can be used to determine a letter grade for a particular score. Very same structure as what we have in our program. Okay, very same idea that we have. if, Elif, Elif. In this case, they had 3 Elifs because they needed to go through 5 different grades. Okay with that?
Yeah.
Any questions?
Nope.
No questions.
Okay. Okay. Well, then let's take a look at logical operators. Logical operators are also in your textbook. They are on page 133. Let's just take a look at that. Page 133. The logical operators are and, or, and not. We saw or being used back in that program where we allowed an upper or lowercase y. And basically, these operators are used to make complex expressions where you want something a little bit more complex than just a single expression. You want to have more than one expression in the if statement. That's where you use these logical operators. And the and operator is used if both conditions have to be true. The or operator is for either one being true, and not just negates not true is false, not false is true. So here's for example some expressions. Here's the and operator being used. X is greater than y and a is less than b. X equals y or x equals z. And here's not x greater than y, which of course would be the same as x less than y. Yeah, the not operator does come into play occasionally, but very often you can get around without having to use it. Okay, well let's look at another example program that uses logical operator. Got one here, the last one that I had planned for today. If 5 and I wanted to do this one for, I've still got age categories up here, but maybe I should say voting permission. So let's say we have a program here that we're going to determine if somebody can vote based on their age and their citizenship status. 2 parts to it. As you may know, a felony also would disqualify you, so we could add even more to this program, I suppose. But let's just base it on age and citizenship. So we're going to ask the user to enter an integer. So notice to get that integer, we have to use input. Enter your age as an integer. But to get the citizenship status, which is only a string, we're going to enter a y or an n. We don't need to use int or float. We just use input alone. So here's the complex expression that uses the logical operator and. In order to vote, you have to be both greater than or equal to 18 years of age, and you have to be a citizen. Citizen has to be y. If that's the case, you can vote. Otherwise, you can't vote. So let's give that a try. Give that a run here. And let's see what it looks like here. So I'll enter 21 and citizen, yes. So both of these evaluated as true. So therefore, this person can vote. All right, let's try it again. I'll do it another run. Let's say you're 21, but not a citizen. Can't vote. Both have to be true. The and operator means both conditions have to be true. Any question about that? By the way, sometimes you can have even more. You could have multiple, maybe 3, maybe 4 or 5. It gets a little complex, but there could be other conditions. Like, actually, I suppose we could say and not felon. equals y. If we had a felony question, I suppose we could do that. And not, right? Okay, that's where that might come into play. Any question about that, folks?
No, but you'd have to put another input.
That's right. We'd have to have another input. Exactly right. Yep, we'd have to have an input for the felony. Yeah. Give it a try. Okay, let's see. It's really a terrible thing, isn't it, to be a felon?
I think so.
You really pay. You don't just pay for imprisonment. You pay for a long time. Okay, so let's give this a try. Okay, let's say 21, and yes, I'm a citizen, and I'm a felon. No. Works just fine.
Can you have ands and ors in the same statement?
Absolutely. Yes, you could. Yeah.
And
You
does
could
it read left to right?
That's right. It could be agent and citizen or something. That's right. You can use,
Okay.
yeah, you can have multiple ors and ands. Lots of different ways. And by the way, we humans are very, very careless about how we use and or. We're very careless about it, but the computer has to be absolutely precise, of course. That's the whole thing with the computers. Attention to detail. It's got to be just right. Just as an example of that, let's say you're running a database and the boss says, give me a list of all the people who live in Tampa and Dunedin. Well, that doesn't sound like that sounds like something you would be able to do, right? Give me a list of all the people who live in Tampa and Dunedin. Well, that's logically incorrect. Your customers live in Tampa or Dunedin. We're very careless about that. If you want to do that with a computer program, you'd have to use the or operator, not the and operator. Okay, well, that's pretty much all I had for you folks. That's most of the content that you need to know for this chapter. I don't know if maybe you want to tackle an extra problem or two. I'd be happy to do that, or answer any other questions that you might have.
I'm comfortable.
Any other questions we can help you with?
I had a question, but you answered it already. So.
Okay.
Nothing else on my end.
Okay. I mean, we could go ahead to the end of the chapter and try one of the examples there if you want.
Sure.
Let's see. Well, I'm going to flip ahead through the book here and see if I can find a good one that we could do. It's funny, there is an age classifier on page 152. I guess that's where I got that idea from. Well, pick one, folks. Which one would you like to try? Not the Roman numeral one. It's kind of a weird one. I'll tell you one that's not too bad, but it's kind of like something I think you're going to find in your assignment, certainly in the practice assignment. Hey, I've got an idea. Let's take a look at the actual assignment here. That's the practice assignment. Let's look at the actual assignment. And by the way, I'm behind in your assignments, so I'll try to get those caught up in the next day or so. All of your grading. Okay, you got 3 programs to write for chapter 3. The first one you have to make your own quiz program. Pose 3 questions that you make up, anything at all. Question 1 should require a string answer, text answer, right? Question 2 should require an integer int, and the question 3 should require a float answer. For each question, your program should respond positively to correct inputs or display corrections for incorrect inputs. So a little quiz program. I think you'll have some fun with that one. That's a totally creative one.
Yeah, that one was fun.
Good. Okay. All right. Now look at this one here. School categories are based on grades. Well, this is very similar to the age program that we tried. Right? Same concept. Instead of entering your age, we're entering a grade level, and then determining whether it's middle school, elementary school, or high school. So that's pretty similar to what we've done tonight. Now here's a payroll program. I did want to talk to you about this one. I'm glad we looked at this. As you may know, if you work more than 40 hours in a week, you should get time and a half for any hours in excess of 40. So if you were going to work out an overtime program, a program to calculate your weekly pay based on your hours worked and the rate of pay, you would have to make a decision to see if overtime applied. So you definitely would have to have some if conditions in there. So look, we've got 2 inputs. Ask for the pay rate, ask for how many hours were worked. Then we calculate the regular pay. Also, we calculate the overtime pay. Even if it's not an overtime situation, you should display the overtime pay, and then the total pay. Now, the next one down is an overtime situation because we've got 44.5. So somebody's getting $25 an hour, must be an SPC graduate, and they're working 44.5 hours. That works out to $1,000 apparently. And it seems, yeah, that works out to $1,000. Overtime pay is $168.75 for a total pay of $1,168.75. I could live on that. Now look at how this was. How did this happen? How did we come up with the 1,000? Anybody want to take a shot at where that 1,000 came from?
The hourly times your 40.
That's right. Your regular pay is your 40 hours worth of pay. So you have to calculate the regular pay with the pay rate times 40. Now, how do you get the overtime pay?
1.5 times 4.5. 1.5 times 4.5 hours. So 4.5 times pay rate times.
It would be like 37.50 times 4.5 hours, right?
Yeah, I think I think you're both on the right track. I think really what you'd want to do is something like this. This isn't a very good place to do it. I think you'd want to do something like this. I think you'd want to say, just working with the numbers, your pay would be 40 hours times the 25. Obviously, I'm not coding here. Okay, I'm just doing this like a math teacher would. Plus 25 times the 4.5 times the 25, right?
That wouldn't work. You got to do your time and a half.
Yeah, you're not figuring the time and a half.
Sorry, yeah, the 1.5 here. I'm sorry. Yeah, probably I should have put the 1.5 here. Put the 1.5 here and the 25 here. That would make more sense. So you get 40 hours of regular pay and time and a half times 4.5 times 25.
So would that all work the same? Yeah, it would.
Yeah, I think that works out to
25 times 1.5 times 25.
Right. So that should work out to that 1,168.75. Now I encourage you to work it out on the calculator when you do this one. Make sure you're doing the right thing. Okay. Check your answer with the calculator. I think you'll see that that's right. Somebody's doing it. I can hear you tapping keys.
Yeah, that's me.
That work out okay?
Yeah.
Okay. Good. Now, where did the 4.5 come from?
OT hours.
Pardon me?
Those are the OT hours, the hours above 40.
True, but how do you know that? How is that calculated? It's not one of the inputs.
Oh, we would assign something that basically says anything above 40 hours, or anything greater than 40 hours would be
Yes, you'd have to have
assigned
an
to
if.
some variable.
You'd have to have an if like that. But let me just, what I want you to do is just focus in on this. Where does that 4.5 come from?
So I will probably go the route of assigning a constant to your work week, which should be 40, and then doing that if else, or if your input is greater than the constant and you use the difference or something like that. I will subtract the input from the constant.
Yeah, that would work. But I still haven't heard the answer that I was looking for, which will help you do this problem. You would do it like this. It would be the 44.5 minus the 40, right? That's where the 4.5 comes from.
Yeah, okay.
So you're going to have to put here hours minus 40 when you do this as an expression with the variables, right? That's the key point here.
Okay.
Okay. Well, I don't have anything else for you tonight. I don't know if you wanted to try one of the problems that's in the back of the book. I think we're pretty much out of time anyway. And it is at 11 o'clock.
Okay.
Better call it a day.
Yep.
Call it a night. I'm very sorry for the startup problems. We should be okay in the future, I hope. I'm going to get in touch with Zoom and see what happened to my other account. But it doesn't work anymore. But we should be fine for next week.
Alrighty.
Okay.
Thank you.
Thank you, folks. Hope
Thank
this
you
helped.
so much.
Thank you, sir. Good night.
Take care. Brad out.